Okay, ma'am. Then without further delay, we are handing over the session to you. Over to you, ma'am.
Okay.
And just a note for the participants is there'll be a session first where there'll be explanation of the concept of binary logistic regression today, followed by the demonstration on Jamovi. And after that, there'll be around a 40-45 minutes of breakout room session where we will practice with different mentors in separate breakout rooms on the Jamovi software, the binary logistic regression. So we are all requesting all the participants to be present on the laptop so that they can share their screen and we can practice together, because without the hands-on practice, this workshop will lose like more than half of its significance. So please, anyone who has not joined on the laptops yet, please join on your laptops and attend the session. That is our earnest request. Over to you, ma'am.
Thank you, Ria, and good afternoon. Am I audible, Ria?
Yes, ma'am, you're audible.
Okay, thank you. So, good afternoon, everyone, and we are delighted to see the young people coming in and hosting such like conferences and webinar and workshops. So, congratulations to IACFM, and thanks for inviting us to be a part of it. So, thank you, Ria, Rubina, Haripriya, and all other executive member of the IACFM, and welcome to all the participants. So I'll just start, as Ria has suggested, that all of you please download Jamovi, and that is the solid version of the Jamovi. Currently, I think 28 version is the latest one. So before you go to the breakout room, you can download Jamovi. It's very easy. I will demonstrate also towards the end of the conceptual session, and then we may all like learn over the Jamovi. So I'm sharing my screen. So we will start this session with a very simple example, because see, all these, the moment you listen to this word regression, or something like survival, or something like logistic, so all these things are, you can combine into one thing that is called the modeling. Because modeling in health sciences, you have got many tools to model. Now, what is this modeling actually? So basically, you do the predictions. Predictions means based on some variable, you want to predict the another variable. And that's how the role of modeling comes. Because with this modeling in health sciences, you can actually like treat patients based on those assumptions or give some therapy. So it has got too much role in the evidence-based medicine. So you can see here that let's begin this exercise with a simple example. And here you can see that there are two columns here. In the first column, you can see that there is a distance. And in the second column, there is a taxi fare in rupees. So you can just see, maybe few of you have also attended many webinars and workshops. So you might find it a little duplication or maybe a revision. So can you make a formula to predict taxi fare from this data set? Okay, any message in the chat box, or you can unmute and answer also. Okay, so Ritaban Guha has written y is equal to 100 plus 10x. Okay, yes. Anybody else? So like if you have to predict the taxi fare for, you can say like for 2 kilometers, so it will be 100 plus 10 into, yeah. So you what you did, you just deducted 10 from both. So it's the 90 plus 10x. So you are right. It's the 90 plus 10 into distance traveled. So this is the linear regression. You are right. This is linear regression because here you are predicting the taxi fare based on the actual distance travel. Pragya has also written the same 10x plus 90. So agree, it's right. So here, if you have to convert it into the equation of a linear regression. So a linear regression, you have got, if I talk about the simple linear regression, where there is only one predictor variable and there is only one response variable. So here there is a independent variable is the x and the dependent variable is the y. So dependent variable means you are predicting this y. So taxi fare is y is equal to, what is this 90? So this 90, it is known as the intercept. Just to introduce few technical terms. So this A is equal to intercept, this 90, which you have written here, like all of you have given the equation. So this 90 is known as the intercept plus B into X. So this B is 10, which is known as the coefficient, and this X is the distance travel, actual distance travel. So with the help of this equation, can you predict the taxi fare for 5 kilometer distance travel? All of you, please do this calculation and write in the chat box. For 5 kilometer? Okay, so Sriram Goswami, Ritaban, they have written 140. So 140 is right. Now, if you see this table, so with this equation, it was 140. And if you see actually the distance traveled, which is here, the 5 kilometer, this one. So what is the fare? If you see in this table, it is the 140. So can you appreciate that the predicted fare is equal to the actual fare? Do you agree? Yes or no? Here, whatever fare you have predicted from the equation, the actual fare was also the same. So please write yes or no. Okay. Okay. Thank you. So now, if you see this, so this is a simple linear regression equation, which we have just constructed. And in biological world, you see that the relationship is not so straight. There's a lot of permutations and combinations, and we cannot get the value of A and B just by seeing the data. For that, you have to use a software. But just to make you understand regarding this, what is intercept, what is coefficient, what is dependent variable and what is independent variable, this example you can remember. Now, let's change the values of the data in this data set. So now can you see the distance traveled in the kilometer that is there in the first column, and in the second column it is the taxi fare in the rupees. So you can see it is ranging from 96, then 112. So based on this 5 data set, can you make a formula to predict a taxi fare from this data set? All of you, please see this data set, and can you make a equation from this data set? So it's a little difficult because you cannot make, so you will have to use a software, because whatever you will try here, it is not going to be successful. It is difficult to find A and B. But with the help of a statistical software, you can easily get the value of A and B. So if you enter this data into Jamovi or even in Excel, you can get the value of A and B. So this, we have entered this data into the Jamovi, and this was the equation which we got. So taxi fare is equal to 72.5, which is the intercept. You can see here, this is the intercept and this is the estimate. So estimate is the 18.8 into the distance traveled. So this was the equation based on the second data set. So with the help of this equation, can you predict the taxi fare for a 5 kilometer distance? All of you, please do this. So 18.8 multiplied by 5, and you have to add it to 72.5. So you can take help of the mobile calculator and tell me the distance. Yes, so 166.5. And one participants have also written that there are two different entries for 2 kilometer. So yes, that can be there. You have seen that with in Ola also, if you hire Ola with the same distance, at one point of time you have to pay some other fare, and the other point of time you have to pay some other fare. So because it is dependent on a lot of other factors, it is not only the distance which is important. So 166.5 was the distance. But if you see the in the table, the actual fare was 170, whereas the predicted fare, what you people have calculated, that is 166.5. So now you are finding that there is a little mismatch between the actual fare and the predicted fare. So how do we define this mismatch? What do we call? There's a technical term for this mismatch where there is a difference in the prediction from the actual fare. And this is known as the residual. So there is a term which is known as the residual. Whenever there is slight deviation from the actual, that value from the actual and predicted one is known as the residual. And this residual, or we can also call it as an error, because this is the error. So the narrower the error is, like in the previous example you have seen, that the actual fare and the predicted was exactly same. So that was in reality, that much accuracy is not possible in biological world, but if it is as near to the actual, then you can say that your model is a very good model. The model fit is, and you will find that the model fit will be very good. So what is the calculation? I think, yes, 3.5. Dr. Anupama is writing, it is 3.5. Agree. So now things become more complex, like I was giving you example of Ola or Uber or any other cab you hire. So it is not only dependent on the distance travel, rather a lot of other factors are also playing with each other, like the traffic conditions, whether it is weekend or weekdays. So I think two participants have raised their hand, Pragya, and I think there was one, Deepak. So do you want to ask something, Pragya and Deepak?
Yes, ma'am.
Yes, Pragya?
Ma'am, what is the difference between the residuals and the error?
Actually, they are same. Error are also known as the residual. So in different modeling, in modeling, sometimes you will see that in the equation also it's written E or error. And that's the residual. So it's same for modeling.
Okay, ma'am.
Deepak, you also raised your hand? Okay. So, so now you can see here that there are a lot of other factors. If the weather, dependent on the weather conditions also, if it is a very heavy rain, then you will find that fare becomes more. If it is very hot also, the fare becomes more or less depending on the situation. If it is a morning time from 8 to 11, if you are hiring a cab, you will find that the fare will be more. So similarly, it depends on the traffic condition. It is dependent on weekend, or whether it is weekend or not, dependent on weather condition. So there are more variables which are now we have added. So now the taxi fare is dependent on, if you make a equation, so A will be the intercept, and now there will be various coefficients like B1 for the distance travel, B2 for the traffic, B3 for the weekends, and B4 for the weather. So this is multiple linear regression. Initially, we were writing the equation that was for a simple linear regression. Why? Because there was only a single predictor variable or this one independent variable. When you have got more than one independent variable, then it is known as the multiple linear regression. Now, if I here you can see that there are three columns. This is the 10 students, this is the attendance of 10 students, and this is marks of 10 students. So here what can you find out? Can you find any relationship between the attendance and marks obtained in this data set? Can you write in the chat box? Please see this data set. So more attendance and more marks. That's what Dr. Anupma and Dr. Muhammad is writing. So agree, if you see it is 52%, then the marks is 68%. Dr. Shriram is also writing the same thing. And if attendance is more like 80%, you can see the marks is 94. So it is directly proportional. That's what Dr. Jalinder is also writing. Now, can you find out any relationship between in the second table? Now I am talking of this second table. So there are 3 columns here. There's 10 cases. In the second one, it is the duration of exercise, which has been expressed as the minutes per day. And then there's a fasting blood sugar. So can you find out any relationship between the duration of exercise and the fasting blood sugar? So when duration is more, fasting blood sugar is less. That's what Dr. Shruti is writing. So you are right. Dr. Shriram is also writing the directly proportional. Dr. Muhammad is also writing the same thing. Yes, so you are right here. It is inversely proportional. So based on these observations, we can predict the marks obtained by students given by their attendance, and we can also predict the fasting blood sugar level of a patient given their exercise duration per day. Now we have added one more variable, which is the gender in both these two tables. So there is a gender also now, and here also you will find there is a gender for prediction of fasting blood sugar. So can you observe any difference in this both data set? So first now focus on this table. We have added the gender, and now can you see any like with the addition of this gender, any difference in the duration of exercise and the fasting blood sugar level? In the first one. So less exercise duration in females in the first one. So if you see this here also females are exercising. If you see this value, females are exercising for 55 minutes also. This one, if you see this value, so females are exercising here for 55 minutes. But yes, of course, in the second table, if you see this, you can see that females generally they are exercising. If you see this value 32, 39, if you see here also 30, 31. So females are generally exercising less than 40 minutes. So now that means there is a relationship between the gender and the duration of exercise. Whereas in first table, you cannot find any relationship between the gender and the duration of exercise. So such things are also there. That's why we say that if there are more in biological world, actually there are more number of predictor variable, independent variable, which predicts the outcome variable. So here we have to see the relationship between the gender and exercise. So here in the first example, gender and exercise duration is not related with each other. And in the second one, like we have seen that generally females are exercising for less than 40 minutes. That's why 30, 31, if you see here, 32 and 39. So there is a relationship between the exercise duration and the gender. So till now we have tried to predict the values of a continuous variable, which is the linear regression, where it is a simple linear regression or a multiple linear regression. And the closer this predicted value, better is the equation or the model. So we wish to predict the fasting blood sugar level based on gender and duration of exercise. We recruited 10 persons, asked their gender, their duration of exercise, and measured their fasting blood sugar. And if I'm using that data to develop a model for prediction, which of the following is the best possible theoretical model? So here you can see model number 1, 2, and 3. And I will request all of you to focus on last 2 column, which is the actual fasting blood sugar. This was the actual and this was the predicted one. Similarly, this was the actual fasting blood sugar in model 2 and this is the predicted one. If you see the model 3, this is the actual and this is the predicted. So now, can you suggest like which model? What about, let's focus on model 3. The model 3 is the best. But do you think that this is really practically possible, that you are 100% accurate? So actually model 3 is the best, but that is not practically possible. So that's not a reality. Okay. Now, what about model 2? What about model 2? Okay. So model 2, you will see that there's a lot of mismatch. That means the error is high. 96, 130, 132, 90, 125 and 105. And model 1 seems to be, like Shruti has written, seems to be practically possible. So model 3 is ideal, but not practical. And practically possible model, which is really acceptable, will be model 1. So for a linear equation, certain assumptions should be met. The first is now you have seen the linear regression. So we are introducing the concept, how the logistic regression. We will learn when and how to apply it, but I am just taking you the journey from linear regression to the logistic regression. Why logistic regression? There was a invention of logistic regression and how it is different from linear regression. So for linear regression, because I assume that all of you have little concept of linear regression. So in linear regression, what is first assumption? That the independent variable and dependent variable should have a linear relationship. So for that equation, y is equal to a plus bx plus this, that, like there are 3-4 more terms. For that equation, a linear line, the independent variable and dependent variable should have a linear relationship. Like you have seen that as the duration of exercise increases, the fasting blood sugar decreases. That shows a linear relationship. As the attendance marks, a percentage of marks, as the percentage of attendance increases, the marks obtained also increases. Again, shows a linear relationship. It can be a directly proportional or a inversely proportional, but there should be a linear relationship. And we also see this linearity in terms of the residual. So residual, like I have told you, it is the difference between the predicted and actual. So here you can see that 96 was the actual and predicted is the 100. So the residual will be 4. Similarly, this residual should also have a normal distribution, which we check by the QQ plot. So now if I like change this, so what have I done here? Here instead of blood sugar, I have written another variable, which is the diabetic foot. Whether the diabetic foot is present or diabetic foot is absent. Similarly, in the initial table, we have taken the marks out of 100. If you just recall the previous one, here you can see that here we have taken the marks obtained. Whereas if you see this, here it is the pass or do not pass. So what I have done in this table from the initial one, here also, if you focus here, yes, any response? Quantitative to qualitative. Pragya is writing outcome is binary. Okay. Dr. Shriram has writing quantitative to qualitative. Agree. So basically what we have done here, that we have changed. Yes, Dr. Jalinder is writing that outcome is dichotomous or binary. So instead of this continuous, we have here we have categorized it as diabetic foot present or absent. Similarly, here in the marks, we have categorized it as uh, categorical. So this is the difference you can see here between the outcome variable. from the in context of the previous one. So if I have to form a linear equation, how will I form? So I will write diabetic foot, and then because the diabetic foot will be my dependent variable. So presence of diabetic foot, yes or no. And then I will write the equation like A, which is the intercept, B1 into gender, and B2 into the duration of exercise. But in yes or no, what I could write? There are only two values which are possible, either 1 or 0. Because if I have given, categorize it, 0 I will write no diabetic foot, and 1 I will write yes diabetic foot. So my equation will be like either 1 or 0, and then towards the right side it will be same. So such linear regression equation is not possible because it has got only two values, either 0 or 1. Then how will we form an equation? How that equation will come if there is no linear relationship between the independent variable and the dependent variable? So linear regression equation is only possible when outcome has a continuous value. So how to convert this yes and no outcome to some continuous value? That is the thing which we have. That's the challenge which we have. How to convert that binary data, categorical data, into some continuous value so that it can satisfy that equation and that assumption. So we can calculate the probability of occurrence of such outcome for each case. So now what we have decided that we can calculate the probability of occurrence of an event. Like here you can say we have written diabetic foot present or absent. So what you can calculate the probability of a male 32 year of age who is doing a 50 minutes of exercise per day. What will be the probability of the occurrence of diabetic foot? Similarly, you can calculate the probability of a female who is 55-year-old and doing 39 minutes of exercise per day. What is the probability of occurrence of a diabetic foot in this female? So for each case, a probability can be calculated. So this is the predicted probability. So 0.05, 0.643, the values which you are seeing here, these are the predicted probabilities. We'll see later how these predicted probability is calculated. Actually, the software calculates the predicted probability for each case, taking all variables into account. So this is the predicted probability. So now what we have done? A categorical data we have converted into the probability. Are you people with me up till this point? What we are doing currently, since in linear regression, the dependent variable is in linear regression, dependent variable is a continuous variable where you have got a range of values like taxi fare. But in logistic regression, or when you have converted it into the two categories, you have got only two values. So now what we are doing, we are trying to convert this. I am just telling you all these conceptual things. These concepts are not needed when you just interpret the table and apply the JAMOV. Listen, when you apply the commands over JAMOV, these concepts, this is running in the background. So you need to understand this as a student of as a researcher, like what is happening in the background. And that's what we are trying to make you understand. So here you can see that this predicted probability it has calculated, and we are now having a range of values. Initially, we were only having 0 and 1. Now we have all these values. But again, there is a problem with the probability value. What is that problem? Because it has got a range. The probability can only range between the 0 and 1. It cannot have any other value beyond 1 and less than 0. Now, based on this probability, if the probability is 0, definitely you will write that there is a no chance of outcome of occurrence. And if the probability value is 1, you will write that definitely that outcome will happen. Now, what will you write when the probability value is 0.12? Please write in the chat box. What will you write? 0.12, mild chance. For 0.93, what will you write? Point 0.93, very low and very high. High chance, okay? And 0.55, somewhere midway, right? Yes. So Dr. Anupma is also writing, Shruti is also writing midway. So 0.12 we can write nearly no chance, 0.93 there is a definite chance, and 0.55 difficult to decide because maybe yes or maybe no. So you will get many such value of probability where it is difficult to predict whether the outcome has happened or outcome has not happened. Now, how to resolve this dilemma? So we need to set some rules for this probability value. So what this software does, all software, whether it is SPSS or JAMOV, they take a cutoff of 0.5. So if the probability is more than equal to 0.5, the software takes it as an outcome occurred. If the probability value is less than 0.5, then the JAMOV or SPSS or any other software takes that the outcome has not occurred. So taking this rule, what will you write in case of a 0.12? No outcome. What will you write in case of a 0.93? There is an outcome. What will you write for 0.55? You tell me that. Because 0.12 and 0.93, it was clear initially also. There was some confusion. 0.55, yes. Outcome present. Why? Because we have set a rule that if the value of probability is more than equal to 0.5, then definitely that outcome has happened. So now, till now, what we have done? We have calculated the probability from the software and we are assigning a group membership, whether the outcome has happened or outcome has not happened. So in the previous question, the calculation of probability will help in the formation of a linear equation, because I said that for multiple linear regression, whether it is simple linear or simple multiple linear, you need an equation. So this diabetic foot, yes and no, instead of yes and no, you can use the value of a probability, this one. So what I may write here in the dependent variable, the value of a probability of a diabetic foot. Now, so you have still you have a problem because probability values as outcome is again ranging from the 0 to 1. And for linear equation, for linearity assumption to be met, the value of outcome, it should be from the minus infinity to plus infinity. It cannot be like from 0 to 1. So now what we should do? So what we do the conversion. So do you know that how this can be converted into odds? So yes, this probability can be converted into odds. And the formula for that is the odds equal to probability in the numerator divided by 1 minus probability. This gives you odds. So the odds, it will not be restricted by the upper value of probability, that is 1. So now, if you have to calculate the probability of odds from a 0.75 probability, what will be the odds? So 0.75 divided by 1 minus 0.75. It will be 3. So Dr. Jalinder is asking me to again repeat it. Yes, Dr. Jalinder? I was telling that for a linear equation, remember in the beginning we learned y is equal to a plus bx. Can you recall, Dr. Jalinder, in the taxi fare example?
Yes,
We
ma'am.
have
Yes, ma'am.
learned that a linear equation is equal to y is equal to a plus bx. And then we have
Yes.
seen
Yes, ma'am.
that equation holds true only when there is a linear relationship between the dependent and independent variable. Do
Yes,
you
ma'am.
agree till that?
Yes, ma'am.
Okay. Now for that, the linear equation, that value of the dependent variable should be from minus infinity to plus infinity. Like a taxi fare. A taxi fare, although in case of a taxi fare, it cannot be negative, it will always be positive. But for linear equation, you can see this will go in this quadrant also. So the assumption is like that outcome variable should be from minus infinity to plus infinity.
Okay.
So do you agree till this point?
Yes, ma'am.
Now, how it will go? Because probability, can the value of probability be more than 1?
No, ma'am.
No, it cannot be. So then
Yes.
from probability, we can deduct another uh, outcome or another value, which is known as the odds. And odds have this feature that it can go more than 1. And
Yes, ma'am.
that's
Yes,
the
ma'am.
example, like, because probability, the equation of odds is probability divided by 1 minus probability. So if the value of odds is, if the value of probability is 0.75, the odds will be 3. Similarly, if you calculate this is the predicted probability. Okay. And if you have to calculate the predicted odds, you can see here that odds can be from 9. If the probability is 0.962, the odds can be 25. Right. So the value of odds will be more than 1. So then it can go up till plus infinity. Right. I'm not talking of minus. It can go up till plus infinity. So all we are doing is to just meet the assumption of linearity. Okay. Again, you don't have to do it. The software does it in the background. But how from linear to logistic, why there is a term? See, in logistic, do you know this logit? What is the spelling of logistic? It is logistic. So that because of that logit function, it is known as the logistic. So I'm just trying to explain you this logit function, what was the need of this logit function? Because many of you will find later in the table that it gives the interpretation as odds or odds ratio. So how come because in linear regression, have you seen odds ratio? No. If you can recall this, I will just go back in the beginning. So I am in 36 number slides. If you go back, that taxi fare. So what was the formula here? It was the actual value, 18.8, intercept and distance travel, and you will get a taxi fare. So here, this is not related to odds ratio or odds. These concepts you will not find in linear regression. Did you? Have you understood this?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Got it.
So you will not find, so that logic, that's why, because ultimately it has developed from linear regression. So that logit function is added in the logistic. And why there was a need to add this logit function? I'm just explaining that. Because then many people and many participants and previously also, they ask us like, what is this logit function? So basically this logit function is what we are trying to explain. That's why, so I'll again come back to that 36 number slide. And here you can, so now can you understand that so what we did, from first we calculated the probability. From probability, we calculated the odds. Why we have calculated the odds? Because odds can go from value more than 1. So this was the calculated odds. So we can have again, instead of predicted probability, we can have a odds of diabetic foot like this. So it can be in the form of linear regression equation. But again, still odds have an issue. And what is that issue? So that issue is odds cannot be less than 0. And the second thing is the value of odds is symmetrical around 0. It is not symmetrical around 0. So what do we mean by asymmetric around 0? So if you say that the odds of diabetic foot among male is 2 times higher than female, then we have to say that the odds of diabetic foot among female is 0.5 times lower than male. How do we do that? Basically, if you have to change the reference level in case of odds, then you have to do 1 by the previous odd. So the odds of, if I say that the odds of diabetic foot in the first, if you see this first statement, the odds of diabetic foot among male is 2 times higher than females, then if I have to say the odds of diabetic foot in female, what will I do? 1 by 2. So it will be 0.5 lower than males. Similarly, if I say that the odds of diabetic foot among male is 3 times higher than female, here the reference category is female. But if I have to say the odds in female as compared to male, what I will say? I cannot say that it will be 3 times less. I have to say it is 0.33 times lower than male. How I have arrived? 1 by 3. It will be 0.33. Similarly, if I have to say that if odds of diabetic foot among male is 4 times higher than female, then we can say that the odds of diabetic foot among female is 0.25 times lower than male. Are you people getting this? Any yes or no? Anupma is writing yes. Okay. So this is just, okay. Shri Krishna is also writing yes. So this is not symmetric. Why? Because if I have to say that the fasting blood sugar of male is 20 milligram higher than female, if I have to say in female, what will I write? That it is minus 20 lower than female with respect to male. Similarly, if I have to say that the fasting blood sugar of male is 8 milligram lower with respect to female, we can say that the fasting blood sugar of female is 8 higher. So this what we mean by the symmetry. But if you see the previous one, this is not symmetrical. In male it is 2, in female it is 5. So for symmetry, now we have to do some other thing. So what we will do, because with this, you will have to make a 2 equation. Odds of a diabetic foot, for one you will write 4, if it is a female as a reference, and if it is a male as reference, you have to write 0.25. That's why what you do, you take a natural log of this. Because if you take a natural log of this odds ratio, you will have a symmetrical value. Okay. And that natural log. So all of you please do this calculation. You open a natural log calculator and you write this odds of this natural log of this odds 4. Please all of you do this. I will also do this. Natural log calculator. So I was just doing this. So click this ln. And if I write 4, so what is the value? It is 1.38. And the other what I have to enter? 0.25. So this ln, take ln, not log. And then 0.25. So it will be minus 1.38. So now it is symmetrical. If in male it is 1.38 high, in female it is 1.38 low. So that problem of symmetry which we were discussing, that is now not there. and that negative value is also permitted. So this log of odds is known as the which function? Logit function. So now we can see, you can write the equation like 1.38 into gender as a reference. So with the help of this Logit transformation, we finally got a linear equation for a categorical outcome prediction. So now I have taken a Logit of this y, which was the dependent variable, a plus Logit of b multiplied by x. So this was, so that linear, simple linear regression, we have taken a Logit function. Have you understood up till this point why we have taken the Logit? Yes, please answer. Have you understood? Have you all calculated the Logit of this? All of you, please do this. I will ask this one. Enter 2 and 0.5. All of you. Calculate the ln of 2 and ln of 0.5. If I do this, you can see. Again, ln of 2. It will be 0.693. And if I do ln of 0.5, it will be minus 693. Yes. So it will be plus and minus. So that Logit function, that helps us to have a symmetrical value and a negative value also. That's why we have taken a Logit function, and that's why this whole regression method is known as the logistic regression. Yes, Ritaban has written a mathematical this thing, a minus x is equal to, yes, right. So again, just a revision of concepts which we have done earlier. So linear equation is not possible with dichotomous outcome. That's why we have converted it. Yeah, the values are symmetric around 0. Yes, Dr. Muhammad, you are right. So that with the single equation, you can explain taking the reference level in both the categories. So we have tried using probability values. So we have calculated the probability, but the probability has got one problem, that it is restricted by 0 and 1. So it cannot extend beyond 1. So from probability, using the formula P divided by 1 minus P, we have calculated the odds, but odds are not symmetric. So we have taken a natural log of this odds, which is known as the Logit function. That has solved our all problems. And this has also solved the problem around the symmetry. So if you take the log of this, we have taken the Logit, log of odds. This odds we have calculated from the probability. And you will see here that this is symmetric, like 0, minus 4.1, plus 4.1, and similarly. So the value, like if you take 0.1, so it is 0.220. And if you take the probability of not happening, because if the probability of happening something is 0.1, probability of not happening will be 0.9. So it will be plus 2.20. Okay. So are you guys clear up till this point? Then we'll go ahead. Anupma is writing yes. Should I take your yes as yes for everyone, Anupma? Or few may people write yes? Palash is writing yes. Dr. Muhammad is also, Ritaban, Dr. Pragya. Okay. So I may go ahead now. So now coming back to calculation of probability, because you will see that everything is originating from this probability. That's why in this software, you will see that there is a, we'll show you, if you click that probability, there will be appearance of a probability column. So you may ask, how do we calculate such probability? So this software calculates the probability, and that is using a technique which is known as the maximum likelihood technique. So basically what this maximum likelihood does, this technique, the computer with so many permutations and combination, that does many iterations. And in iterations, the value of probability, which is very near to that predicted one, because in linear regression, you know that there is a line of best fit. So that line of best fit is drawn by the computer where the distance from the actual value is minimal, where the residual or the error is minimal. So similarly, this also calculates, the computer also calculates these probability in many iterations, and it finally takes that value which is very much near to the predicted one, actual one, and that it labels it as a predicted probability. So this examples in the next few slides are only for illustrative purpose. Actual calculation is a little difficult. So with the addition of more and more variable, different combinations may occur in a data set. So I think I'm not going to show you in the big data set, that is the Excel, that is not needed since you have understood the concept. So to calculate the probability of outcome for each case, software first make an equation in the background like this, B1, B2, B3 and B4. And here it is the estimate associated with each predictor variable. And to get the best value of B for each predictor variable, so that it should be very much near to the actual one. So this was the how we have arrived till the calculation of probability, from the probability to odds, from the odds to logit. Now coming to the logistic regression. So in logistic regression, you will see that the response variable, it is also known as the outcome variable, or it is also known as the dependent variable. Similarly, there's another definition of variable which is known as the independent variable or predictor variable, or it is known as the explanatory variable. So with the help of fewest possible predictor variable, we want to predict whether admitted newborn will get a sepsis, whether a family will fully immunize a child. So these all example which you can see here, these are example of a categorical outcome variable, that too binary. But here there is a problem. There are many predictor variable in any of your example data set or in your research. There are many predictor variable. So which variables to take as a predictor variable? So you need to choose few most probable predictor variable which you think can predict the outcome of interest. So there are two ways to decide for that. We take the criteria of p-value also in unadjusted odds, and then you enter those variable in the final model. So suppose you sorted out 10 most probable predictor variable based on your best judgment, and you will run the statistical analysis to find out the most significant variable. So you see the p-value, like I said, and then you find the best out of those 10 variables, which are the most significant. So you run the analysis one by one, and that we call as a unadjusted odds or the crude odds. And you see the p-value. So you are a little lenient in selecting the variable. So you select the variable where the p-value is up till 0.2. So why we have not set a criteria of 0.05 here? Why we are lenient in selecting a variable having a p-value of 0.2? Can anyone answer this?
So we can include the number of variables, more number of variables.
Yes, agree. And there are chances, and it has been seen from the previous experience, that variables who are significant level is 0.2 with a lot of in the adjusted odds, when other variables also comes into picture, their significant level actually increases. So there are chances that from 0.2 they will go to less than 0.5 also. So that's why we take the variables which are up till where the p-value is up till 0.2. So now the predictor variable which we have chosen, that should it be a categorical or a continuous? So it is up to you. For a continuous, the interpretation is different. For categorical, the interpretation is different. So many times you will see that the people find it easy for interpretation if they have categorical variable as a predictor variable. So they change their type of variable from continuous to categorical. But it is up to you how you want to take that particular variable as a categorical or a continuous. Like in this example, you can see we have taken one table from an article, and where it is showing that what are the predictors of the postpartum depression. You can see the relation of some variables with the postpartum depression. So these all variables are predicting the occurrence of postpartum depression, and they have taken like vitamin D, age, BMI, education, high school and all, and economic situation. So there you can see there are two columns. In the first one, which is this one, this is the unadjusted odds, or which is also known as the crude odds ratio. And in the second one, you can see that there is a adjusted odds. This is the adjusted odds. So here you can see that, just for example, this one, a good economic situation. You can see here it was not significant. It is 0.38, and if you see the confidence interval is having the value of 1 in between. That means it is not significant. But when it was taken with the multiple other variable, it became significant. The odds ratio has increased. It is 0.748, and also it is like borderline significant. You can see that it is 0.05. So that's why with this example, I just wanted to make this point that initially that variable might not be significant if you take it as an unadjusted one, but when it is there with all other variable, it becomes significant. So that's why you should be lenient in selecting the variable. So you may land up in either of three situations. All 10 probable predictor variables are significant, or none of the probable predictor variables are significant, or few of the probable predictor variables are significant. So this is the most common situation, that the few of the predictor variable which are significant. So now what to do next? So we use the selected predictor variable for logistic regression. Now logistic regression, like we have seen, for every probability of dependent variable, it can be converted into log odds by finding the odds ratio. And the log odds algorithm, which is also known as the logit function, it uses a certain formula to make that conversion. So logistic regression, what are the characteristics of this binomial logistic regression? So it predicts the probability for a dependent variable, and the dependent variable should be dichotomous in nature, because if it is more than 2, then there are ordinal logistic and there is a multinomial logistic. So we are covering multinomial logistic in this session, which we will learn tomorrow. So that multinomial logistic regression, if there are more than 2 levels, then the choice of logistic regression will be different. And here the independent variable and independent variable are a combination of both continuous and categorical. So if you just see the difference from this linear, so in the linear regression, you can see that the dependent variable is continuous, whereas in logistic regression, the dependent variable is categorical. So if I want to predict at the time of admission, which patient of COVID may need ICU, so which type of regression I should use? Linear regression or logistic regression? If my research question is this,
Logistic, ma'am, yes or no?
yes, logistic. Why logistic? Because the outcome is where the patient, whether they will need the ICU or will not need the ICU. Again, this is a binary. So now measuring odds ratio, there are two types of odds ratio in logistic regression. There's an unadjusted odds ratio. What do we mean by unadjusted? When there is only one independent variable or the predicted variable, which is predicting the odds of that outcome, that is known as the unadjusted odds. When there are more than one variable, independent variable, this is known as the adjusted odds. So you will see in most of the article, they give both type of odds, unadjusted odds and the adjusted odds. So like many of you in many workshops, you people ask like, can you use chi-square test to like 2 by 2 contingency table to calculate unadjusted odds? So yes, you can do that, but in Jamovi, you can do, because for if the variable is continuous, then how will you calculate the unadjusted odds in 2 by 2 table? For categorical, yes, definitely you can do. If the independent variable is categorical, using the chi-square or 2 by 2 contingency table, you can calculate the unadjusted odds. But for continuous variable, you cannot. So that's why you should use the Jamovi for the calculation of unadjusted odds ratio. So now there are certain assumptions. So till now, you have just seen the basics of logistic and how it is different from linear, what is that logit function, and how to and why we have introduced that logit function in the logistic regression. Now you have decided that, okay, the choice of test is logistic regression. Then there are certain assumptions which needs to be fulfilled. Why you need to fulfill these assumptions? What will happen if you don't go and check these assumptions? Why to? Because many times even the PG students, they come to us and they ask, ma'am, why do we need to test these many assumptions? Why can't we simple run the test? Yes, Dr. Anupma is very right. The model will be very inaccurate. The prediction will be inaccurate. And that's why in evidence-based medicine, if you are making wrong predictions, there will be likely chances that your clinical judgment will be impaired. And like if you are publishing also your research work, there also it is needed that if you are going for any prediction or model, you should, yes, it will be less robust. Agree. So that's why whenever you do the write-up, you should always mention that you have checked for these assumptions and what was the result of those assumptions. So here you can see that there is one dependent variable, which is dichotomous. So we know that, and that dichotomous is a nominal variable with two outcomes. That is first assumption. Second assumption is independent variable should be either measured on a continuous scale or on a nominal scale. Here we have not mentioned the term ordinal. Why? Because even if you enter the ordinal variable as one of the independent variable, it will give you the result in a form of a nominal scale also. Now, I assume that all of you know the difference between nominal and ordinal. Nominal is where the order does not matter. If you change the 2 to 1 or 1 to 2, that order does not matter. But in case of a ordinal, yes, definitely the order matter, like mild, moderate, severe. You cannot make severe as first category and moderate as 2, like mild as 2. You cannot jump the classification or jump the category. But in nominal, if you like, if 0 is for 1, 0 is for male and 1 is for female, you can reverse the code. You can do like 1 is for male and 0 is for female. So that's the difference between nominal, where the change of order does not matter. That is the nominal. And in ordinal, the change definitely, it matters. You cannot change. Now, there should be independence of observations. That's a study design issue. And we know that if you have counted one individual, then you will not count that individual in any other classification. The second is your minimum of 15 cases per independent variable. So that's the sample size criteria. If you are taking 15 cases per independent variable means 15 outcome. Like if your research question is how many cases will need ICU admission. So you should know if you are using 4 variables, at least you should have 60 patients who have been admitted to ICU along with all other cases of COVID. So this 15 cases per independent variable, there is a range. Many author, they will say that it should be 10. So minimum is 10 and maximum is 20. And in moderate, you can say that 15 cases. So we always say at least 15 cases should be there, 15 cases per 15 outcome rather. Cases means outcome because it is binary. So in binary, there is something happening and something not happening. So for one independent, like if you have 10 independent variable, so you should have at least 150 outcome variable. Outcome happened, then only you can take 10 independent variable. Otherwise, if you take many independent variable, and if those number of cases are less, then your model will be not a very good model. There will be a data sparsity bias, and that rigor or the robustness of model will be compromised. So that's why you should be very careful, especially in clinical setup. You will see that PGs or for thesis, they come to us and they want to apply these prediction models or modeling, but the number of outcome is very less and their predictor variable is very large. In that case, you should select the basic minimum, very few predictor variable. Then in less number of cases, you can make a prediction equation. Now, those are the 4 assumptions. There's another assumption which is known as the linearity, which we have done earlier, that assumption that independent variable and the dependent variable should be linearly, associated with each other. So ideally, it should be tested using a procedure which is known as the Box-Tidwell procedure. In SPSS, we do that. You can do it in Jamovi also, but that's little complicated, and that's a 4-5 steps procedure. So just to keep this simple, we can test this linearity using the model fit statistics and pseudo R-square statistics also. How to do that? So we will see these things when we see the when demonstrate it in the Jamovi. So the model fit statistics is the like p-value. It says about the significance of p-value. If the p-value is less than 0.05, you can say that it was linear independent variable and the dependent variable. And if the value of pseudo R-square, it is between 0.2, more than 0.2 or 0.2, you can say that it is linearly associated with the independent variable. The next assumption is about the multi-collinearity. What is multi-collinearity? So multi-collinearity is because there are many independent variables. So when there are 2 or more independent variables that are highly correlated with each other, that create confusion, that which independent variable contributes to the variance explained in the dependent variable. And this is detected by the inspection of a VIF. Jamovi gives you, here we have written the correlation coefficient. So yes, the value of correlation coefficient should be like less than 0.8. And this is the VIF should be like, you can say it should be less than 10. It should not be 10. So yes, Dr. Pragya, I'll explain this pseudo R-square. Once I've introduced the term, I'll explain it a little in elaborate mode when we come to the Jamovi part. Okay. And VIF is the variance inflation factor. You are right. So this is about this multicollinearity. It imposes a problem in the interpretation. So now characteristics, what is the what are the characteristics of this logistic regression? So it predicts the probability that an observation falls into one or two category, and it is based on one or more independent variable. So binomial logistic, just the revision of what we did earlier. So binomial logistic regression, it estimates the probability of an event occurring. So if the estimated probability is greater than equal to 0.5, then SPSS or the Jamovi classifies the event as happening. And if the probability is less than that, it classifies it not happening. So this we have discussed that linearity, this logit function is the most important. And but we don't use this Box-Tidwell procedure. Rather, we use this pseudo R-square values. So model fit statistics like if it is 0.2 to 0.4, we say that it is the good, the goodness of it is okay, and it is linearly associated. And then there's another which is known as the deviance statistics. So this pseudo R-square, it tells you regarding the goodness of it. And this deviance statistics, it tells you regarding the badness of it. So that's why the pseudo R-square, we want this to be more. And this deviance statistics, which is again expressed by these two terms, which is known as the Akaike inflation criteria and Bayesian inflation criteria. So Akaike inflation and Bayesian inflation criteria, these are two model fit statistics which tells you regarding the badness of it. That's why we want these values to be less. Whereas we want the pseudo R-square values to be more, which is between the 0.2 to 0.4. So now coming to outlier. So how do we detect outlier? There should not be more outlier in our data set. So in case of a regression, there are basically three types of anomalous data. Anomalous means which is high and different from other data. So outlier is defined as data which has got a very large studentized residual. So this studentized residual is a type of residual when we express it in terms of a standard error. So here you can see that this is the graph between the predictor and outcome. And here the outlier, the value is very away from the line of best fit. The second is in the high leverage. You can see here that high leverage is a value which is away from this value. So it is the value is in line with the other values, but this is not clustered. Rather, it is very away. So this is known as the high leverage point. So both these outlier and high leverage, you will see that they are not changing the regression line. This solid line is when there is no outlier, and this dotted line is the regression line when there is an outlier. So you can see here that it is not changing the regression line much. In fact, the slope is same. Here also you will see that it is not changing the regression line much. The slope is almost same. But a Cook's distance is the distance when you take both these into account. And Jamovi gives you the Cook's distance. So what is a Cook's distance? A high influence observation, which is both an outlier and has got a high leverage. That is known as the Cook's distance. So outlier don't move the regression line much, neither do the high leverage point. But something which is both an outlier and has got high leverage, that has got a big effect on regression line. And these points are known as the high influential point. And we operationalize the influence in terms of a distance known as the Cook's distance. So the value of Cook's distance should be less than 1. So multicollinearity, we have seen that now to understand this multicollinearity, so our data, it should not show multicollinearity. So it happens when we have got two or more independent variables that are highly correlated to each other. Okay, so I'll just give a few example of this multicollinearity. So let us understand a scenario where we want to predict a person's cholesterol level based on various health-related features. So we intentionally introduce multicollinearity between two predictor variables.
Hello, ma'am.
Yes,
Hello,
Dr.
ma'am. Yes, ma'am. That the model of that means outlier are high. That is high leverage. So though data is of continuous type, we are plotting that. That
Yes,
means
yes.
those are individual observations.
Yeah.
And so it is for continuous type of data.
Yes.
Okay.
It is for just for example, I have shown you. In case of logistic also, there are high leverage and because ultimately that linear equation that it is plotted, linear line is plotted in case of a logistic regression also, not in the software, but in the background again, it also calculates the predicted probability. So the difference between the actual and the predicted one, it gives you the residual. And the residual, actually, all these analysis we are doing on the residual or the error term. So that's why in logistic also that high influential point, this calculates based on the Cook's distance. And that Cook's distance is a distance when that individual value of that that independent data set, that is it is deviating the the angle or the slope of the regression line. So here you can see this multicollinearity between weight and BMI. So this is the weight. So of course I think this weight is I mean this is not a true data because the weight is like 200, 155, 190, very high weight, and this is BMI. So because the BMI is derived from the weight only, so if you take both these, there will be multicollinearity between the weight and BMI. Similarly, the lung capacity. So another example is if you want to predict a person's lung capacity based on various physiological factor. So if you are taking age also and arm length also. So because these two variables are highly correlated with each other, closely related, because the taller individual might have longer arms and vice versa. So there will be problem of multicollinearity. So these are some example of multicollinearity. So how to check for that? You can do the inspection of correlation coefficient, but this gives you the value of VIF, and the value of VIF should be less than 10. So this we have done. Outlier, I have told you that this measures the Cook's distance, this GMOV, and its value should be less than 1. And this was one, we will see the exponent calculator, how this estimate, if you take a exponent of that, because it calculates the estimate. And if you take the exponent, then you can calculate the odds ratio. Okay. So we can take a break of 5 minutes and then I will demonstrate the GMOV and then we'll go to the breakout room. So it's 336 by my this thing 337. So we are here only. So we will start the session on at 3:42. Yes, you will be provided with the recorded lecture. So this is the article which we have shared with you. Reasons for surgery cancellation in General Hospital, a 10-year study. And this is again the author, they have did a research on the data set of 10 years and they have seen the reasons for cancellation of surgery. What was the reason for, like, whether it was driven by gender or some weekdays. So they have taken various variables. If you see the data collection, they have utilized the data from the electronic medical record and they have done the analysis. So if you see the statistical analysis, here in the data collection, the reasons for surgery cancellations were classified into patients and hospital factors. Patient factors, I think somebody else can read it for us. Yes. Can someone volunteer to read these highlighted part?
Yes, ma'am. Yes, ma'am.
Thank you.
The reason for surgery cancellation were classified into patient and hospital factors. Patient factors included receiving additional treatment and screening before surgery for sudden changes in the clinical condition, refusing surgery, delay or due to the patient incomplete surgical workup because of taking medication that the patient was not supposed to take before the surgery, or not fasting before the surgery, change in medical status or treatment plan, and others. Hospital factors included surgeon availability, operation in another place, scheduling error, lack of beds, unavailability of equipment, incomplete medical evacuation, or other.
Thank you. What about this statistical analysis part?
The multivariable logistic regression model was used to assess the factors associated with surgery cancellation. Pre-operative diagnosis was excluded from the analysis due to multicollinearity. Additionally, we identified important determinants through the stepwise selection function in the model options. Subgroup analysis was performed according to the urgency of surgery. Data analysis was performed using SAS software. Yes.
Okay, thank you. So you can see that here they have also removed one factor, this preoperative diagnosis, because of the multicollinearity. And how they must have arrived at this multicollinearity based on what statistics?
VI factor
Yes, VIF, how much?
less than 10.
Less than 10 should be included. If it is more than 10, then you have to remove it.
Okay,
Okay.
but out of two factors, which we have to remove? Two variables.
That you will see with the, in the data set. It gives you that particular variable.
Okay.
Because it gives you the VIF for each variable. And
Okay.
multicollinearity means it takes, if you see that output in Jamovi, it will be very clear which to remove, which one to remove. But you should remember that more than 10 should be removed. So this was this thing. We have shared the Excel sheet with you people. I hope all of you have downloaded the Jamovi, and then I'll show you in Jamovi how to. So this is the data set. I'll come to the data. So this is the data, how to import have we shared them the Jamovi sheet? Okay, we have shared the Jamovi, but for those of you who don't know, if you have any other data, you can import it. So so this is the Jamovi. How to open this? Go to this window icon on your desktop, type Jamovi, and you can open Jamovi if it is a blank sheet. But since we have shared the Jamovi file with you people, if you open that file, you will, if the software is installed, you will find this data set, right? So this is the data. And now explaining to, if you see the Jamovi interface, you can see these are the options, like this one. I will click this and I will delete. So I've removed all the previous analysis which we were doing. This is the data. If you have to import any data set, click on this, click on this open and browse that file. It can open any type of data, whether it is in Excel or CSV file or even SPSS, JASP, any other data file. Now coming to the options, you can see this is variable. If you double click this, you can see various type of variable. So like if you double click this, you can see the gender, and this is the measure type like nominal, ordinal, all these type of variable. It is there since it has already, we have done that. And these are the levels like coding. Female is 1 and the male is 2. Similarly, if you go ahead, there is this arrow is there. So keep on moving. You can see age. Age is a continuous data. Then again, you can see we have converted from age, we have converted it into age group also in the categories like more than 20 years, 20 to 60 and more than 60. Because this paper, and we have created this data sheet based on that paper, this one, which we were just, so this the data set we have created for the this workshop. These reasons for surgery cancellation in a general hospital. And then you can, if you go ahead, you will see the chronic disease, no hypertension, diabetes. So you can see various like 0, 1, 2. But again, in output, you will see that in SPSS, you will find that coding is there. But here in Jamovi, it gives you the original variable also. So that's how you can see the various type of data variable, OPD versus IPD. There are various departments like ENT, general surgery, OBGY. Then there are anesthesia type, whether it is a general anesthesia or a regional anesthesia. And then the seasons like summer and winter. Similarly, the days of the week like Monday, Tuesday, Wednesday. Emergency versus planned. Cancellation done. So this is our outcome variable. Cancellation done. Cancellation means surgery cancelled or surgery done. So done is 0 and cancelled is 1. So since we are seeing the reasons for cancellation of surgery, so we will select this one, right? So these are the various data type. Variable type, this is the data. Now coming to the analysis, you can see if you click this analysis, you will find many options in our this ribbon, the upper one. So there are modules you can install, those modules where you need many other, but I think basic one, they have this regression. So that basic, if you install that, you have this regression one as a option. So if I click that, you can see in regression, there's a correlation matrix, partial correlation, linear regression. And in logistic regression, you can see that there are 3 types of logistic regression. So I again told like this, today we are doing binomial, where the dependent variable has got 2 levels. Tomorrow we'll do the multinomial, but again, there's ordinal also, which we are not discussing here, but it can also be like you can see our previous videos, it is available on the website and our YouTube channel also. So click on this binomial logistic. If you click on this binomial logistic, you can see that this window appears. So this is like for the dependent variable, you will see this sign, that this flower sign, this is for the nominal variable. So dependent should be categorical. And then there are 2 boxes. This is for the covariate and this sign is for the scale variable. Scale variable means continuous variable. And then factors. So if you see the factors, all the ordinal and the nominal variable, the categorical variable that should be entered here. So first, there are so many variables. Which variables I should be taking in my analysis or in my final model? How to decide for that? Okay. So I said that it should be based on 2 criteria, whether it is a clinical judgment and statistical significance. So for that, I need crude odds ratio, the p-value of crude odds. So how I'll do that? Here in the surgery cancellation, this is my dependent variable. So I'll enter this dependent variable here, surgery cancellation. And then I may see the other covariate. So I will first enter gender. So gender I will enter here in the categorical one. And if you see the now if I have entered that, you will see that nothing is getting reflected. So first you see the reference value. So here you can see that reference is done. So but you want this reference it is giving you in context of the surgery done versus surgery cancel. Now coming to this model coefficient, this you have to click odds ratio. So if you click this odds ratio, and then you will see that here, just a sec. Now here you have to enter the gender. Because in first one, I am entering the gender. In block one means this is the model builder. You are entering the variable one by one. So I have entered gender. And if you see this, what is the p-value? P-value is less than 0.01, less than 0.05. So I will include this gender in my final model. Now again, I'll move this gender back. So I'm right now what I'm doing, I'm just calculating the crude odds ratio one by one, seeing the p-value and trying to decide what are the final variable which I have to enter in my model, right? So now I'll move this back. I'll take the age. So if you take the age, what is the p-value of age? It is 0.19. So should I take this as my model, as a variable? What is your opinion? Should I be taking this?
To 0.2 onwards.
Yeah, up till 0.2 we can take. Since we have decided that we will take up till 0.2. So since it says it is up till 0.2 the p-value, so I'll include this. Okay, Dr. Anupama?
Ma'am, how to add that odds ratio that is in the output?
Okay. Okay, odds, I will tell you later. I have their model coefficient. I will just uncheck this. Now, no need to see for the odds ratio. Now, only see the p-value.
Okay.
Unadjusted odds, you can do that because you have to enter that value also. But if you come down, there is something known as the model coefficient. Can you see this? And there is an option of odds ratio.
Okay.
If you click this, it will come.
Okay.
So for I just wanted to show you the unadjusted odds also because you need to report the unadjusted odds. Remember, we told that there should be two columns, unadjusted odds and adjusted odds. Generally, the result is presented like that. And then if you can click the confidence interval also. Now coming to the other variable. So this age also I am taking. Now I will see the chronic diseases. So chronic diseases I have entered here. Age I have made two variables, like there's a continuous and there's a categorical also. So right now I'm using continuous, you can use the categorical also. So if you see this chronic diseases, you can see the value of p-values. It is 0.5, 0.5 and 0.8. So should I take this chronic disease in my final model? What is your opinion?
Yes, ma'am.
But why p-value is 0.5? What we have decided?
0.2 and above.
Not above.
Okay.
0.2 and below.
Okay.
Ideally, we should take it up till 0.05, which is significant. So what we write that the variables which are significant in the unadjusted, which we call it as a univariable logistic, univariable analysis, because this is a multivariable. So don't use the term variate. You will see that many times people use terms univariate, multivariate. No, it should be univariable, multivariable. Why? Because one variable is one predictor variable. So here, since only one predictor variable and this is writing as 0.5, so we will not include this chronic disease in our final model. So this will not be there. Similarly, admission type. If I enter that in my this thing, so what is the value? So admission type is, you can see the p value is less than, yes.
Ma'am, if one value is less than 0.2 and another value is less than 0.5, then should we take the chronic disease or not?
Dr. Pragya, can you repeat your question?
Ma'am, in the chronic disease, that is diabetes versus no hypertension and diabetes, hypertension versus no
Okay,
hypertension.
you are asking like levels. Okay. So your question is like, if in the various levels, if one is like 0.5 and the other is like 0.2,
Yes.
then you may take, it, even if one is significant. Okay, so then I'll enter the department type. So similarly, one by one, you see like what is the value of P. So here you will see that the same thing. One is significant, the other is also significant, but the third one is not significant. Can you see, Pragya? It is 0.8,
Yes, ma'am.
0.05, this is 0.01. So you can see
Yes, ma'am.
that I will not, then I will take this anesthesia type, this admission type, right? So similarly, you can decide to take which variable. So till now, I have not taken this, I will take department. And then I might take the season. If you see the season, again, season is, it is 0.9. So I will not take this season also. So season also I will not take. So this is how you decide. So this I have shown you how to decide which variables to take in the final model. And you can write similarly, since only those variables were taken where the value of P was less than 0.2. So I have selected. So this was the unadjusted odds. Now I will take all other variable together. So I will go with this gender, age, chronic diseases I don't have to take, admission type, yes, department, yes, anesthesia type, yes, season I don't have to take, emergency status, yes, probably. Okay. And now come down. So now you can see this. These are the various reference level. So this will tell you odds in male as compared to female in these in IPD versus OPD, and here also it will give you that table. And if you come, these are the assumptions check. So click on this linearity, collinearity statistics. Now coming to model fit measure. Can you see this model fit measure? So this deviance AIC is there. There is an overall model test also. So click on that. So this deviance AIC and BIC, this is the badness of it. And this pseudo R square is the goodness of it. So Pragya also asked one question, what is this pseudo R square? So there are various types of pseudo R square. Basically, what is a R square in linear regression? So that is which is the coefficient of determination, which tells you regarding, which is calculated based on the OLS, that is the ordinary least square regression, which is based on that difference between the values. And this is the variance explained in the dependent variable, taking together all those independent variables, right? That's what the interpretation of R square. But these are called as pseudo R square. Why these are called as pseudo R square? Because here it is calculated based on probability. These are not the actual values. And these probabilities are calculated based on the maximum likelihood estimation, which we have seen in the logistic regression. That's why they are not the true R square. They are known as the pseudo R square, right? And this basically explains the value, the interpretation is also the same. So you see the improvement over the null model. And then you say, like, if the value of this McFadden R square is 0.15, that means this model is 15% better than the null model. Null model means when there is no factor, is that it is only intercept, there is no variable. So there is a 15% improvement. So at good is like when the value of this is up till 0.2. Here also, then you can write that 15% variation in the dependent variable, which is the like a surgery cancellation, is dependent on these factors like gender, age, admission type, etc. And this is the overall model test, which tells you that this is significant model, which is happening, or which it has created. You can click this 95% interval, and you can also come down. I just want to show you one thing. This, no need to do this. That's why I'm closing this. This ROC and accuracy specificity also, I'm not touching this for now. If time permits, we can see it tomorrow. And then
And can you please explain the deviance, AIC and BIC?
AIC and BIC, the value should be less. So if you see this, it actually, it is just the smaller the value, the better it is. So it has not got any like, you can say here, you can see that AIC is 433, BIC is 471, but you don't have any reference value here. So if you make like 2 or 3 model, I'll just show you in a stepwise regression. Then in that change, you can appreciate this AIC and BIC. So just hold for few minutes. I'll show you the stepwise. Here I have entered all the variables together. So there is something known as the stepwise, or which is known as the forward and backward. So I'll show you that also. Then you will appreciate these deviance, AIC and BIC in a much better way. Is that okay, Pragya?
Sure, ma'am.
So now coming to this, so I'm just not clicking this for now, or you can, even if it is there, no problem. So first, let me explain this table. Then I'll tell you other thing. So here, just a sec. You can see surgery cancelled. No, okay. Reference is surgery done. If you check here, yeah, this is okay, because this is giving you the surgery. You have just checked the reference level. So now you can see here that this is the gender. This is the estimate, 1.09. So this is the logit. If you have to take the exponent of this, and that will come as 2.79. So 2.97. So all of you, please do this. You do the exponent of this estimate. Okay, so I'll just show you. There's an exponent calculator. This was the exponent calculator. So E divide this thing by, what was the value of that? 1.09. So basically, this takes the exponent of this estimate, and it calculates the odds ratio. 1.09. So 2.97. So see, this value is 2.97. Can you see this 2.97? So basically, this is all exponent E to the power. This is the value of odds ratio. Okay. So now coming to the interpretation, how will you interpret this odds ratio? 2.97. Yes. Can someone tell me because it is significant. See, I will see the significance value. This is significant. Age is not significant. Admission type, it is also not significant. Then again, this is significant. And this anesthesia type is significant. And this is also significant. So let's first understand this gender, male, female. So how to interpret this 2.97? Yes, Pragya, can you explain this? Or any other person? I just asked because she was the last one to maybe probably I addressed. So Dr. Anupma or Dr. Muhammad, anyone?
Odds of cancellation of surgery are 2.9 times more in males as compared to females.
Yes, very true. So it is giving you just you have to see the reference level. Since reference here is the female, so it is telling you the odds in male. So 2.97 times. And if you have to like do it in percentages, then how you will do? You will like do it like -1. And then you can do like 197% more in male if you have to express it in percentage. But generally here, so reference level, if you see this reference, it gives you the reference. Otherwise, here also, the things which are written later, like regional is first and general is second. So it is taking the second one as reference. That means male is first and female is 2. That means it is giving you the odds in male as compared to female. And you can check the reference level here also. And if you wish, you can change the reference levels also. This is not there in, okay, that is there in the SPSS also. So Dr. Anupma, have you understood how to, okay. Similarly for age. So for age, how do we write? We are saying that 0.99 times. So every 1 year increase in age, the odds of, and you can express it in percentages also. Since it is in minus, so if estimate is in minus, the odds ratio will be less than 1. If estimate is in plus, the odds ratio will be more than 1. So you can write that 100 minus 99. So 1% less chances of cancellation with every 1 year increase in age. So you can express it in percentage also. Similarly, for how to explain this planned versus emergency? Yes, can somebody else try for this, explaining this odds ratio? 2.06, which is significant. So this
When
is
the
giving
odds of cancellation of surgery
yeah.
is
Sorry,
2 times, the odds of cancellation of surgery is 2 times in case of planned as compared to emergency.
Okay, that means planned the surgery was getting cancelled more, twice more as compared to the emergency. Okay. Did you get it? So this is
Yes,
how we,
yes, ma'am. Yes, ma'am.
okay. So this is the interpretation of odds ratio and p-value. So generally you can copy paste this whole, right click this, copy and paste it into your result section. I'll tell you one more option where you can calculate the both unadjusted and adjusted odds together. But first we let us understand this. So now coming to this, I'm just closing this. So remember here, this I'm not telling you. And coming to this collinearity. So see, it will give you the VIF of all the variable. Can you understand now, Dr. Muhammad, that see the VIF value of gender, it is 1.76, age is 1.01, admission type 4.34. So all the VIF values are less than 10. So that's
Okay.
why you can write that there is no multicollinearity.
Okay.
And coming to
We need not to remove any variable for that.
no, then we will not. If any variable would have been a value more than 10, then we would have written that this variable we are removing because it is creating a problem of multicollinearity.
Okay.
The way they have written. Remember?
Pre-operative like that they have.
Yeah. You are right. Very good. Good memory. Pre-operative classification they have written. So correct. Now coming to, I just wanted to show you one more thing. There's predicted values. Yes. So first I'll show you predicted values. Dr. Shamshad is telling me to do it one by one. Otherwise, there will be many columns and then you people will be confused. Yes. So can you see this predicted probability? So this is the probability which is calculated like like taking those maximum likelihood estimation. And now you can see. So taking your criteria, if it is 0.9, then ideally the surgery should have been cancelled or happened. If I am taking outcome of a cancellation. So actually the surgery is cancelled and predicted is also saying that it is cancelled.
Yes.
So it is the correct classification?
Yes, yes.
Okay. Here also if you see surgery is done and it is writing that 0.1. So it is less than 0.5.
Yes.
So is it the correct classification?
Yes, ma'am. Yes.
Now see this.
It should have been done, but it is cancelled.
Yes. So this is a wrong
Mismatch.
group membership. Yes. Now see this. This is cancelled.
Oh,
But it is 0.188. Ideally, it should have been, and it is very less.
yes.
Similarly, if you see this, this is okay. Done and 0.01. This is okay. This is done and 0.05. This is also okay. So similarly, you can, in SPSS, it gives you the group membership also. But here you can see the predicted probability and you can just check how that classification was done. Whether it is rightly classified by your predicted model or wrongly classified. Are you getting it, all of you? The way we have learned the maximum likelihood probability and like it is being calculated here. Do you understand this group membership, how it is misclassified? We have taken a criteria of 0.5, remember? 0.5 and more than 0.5, that means surgery cancelled. Less than 0.5 matlab surgery done. Okay.
So, ma'am, we already have the outcomes of the data.
Yeah,
And
this because on the basis of this outcome, we are doing the modeling.
okay. So for future predictions, whether that means we can use this as a basis.
Yes. Yes, true. Any other case, any other data if you collect, and if you make this, depending on your model fit statistics and the robustness of your model, you can say. And that's what we use. Like if a female comes, you can say that, yes, most likely the surgery will be cancelled. Or a male comes and you can say, yes, if the odds is twice, then most likely your surgery. I mean, you can think of obviously these things, what you say to the patient and not. So you will keep in mind that seeing the previous 10-year data, you have seen that male, the surgeries are getting cancelled more than the females, right?
Okay.
So now coming to other option, which was the residuals. So you can click, you can click the Cook's distance. Initially when I tried, it was not appearing because we have explained. So if you come to the data set, this is the Cook's distance. So Cook's distance is for the individual data point. The value should be how much?
Less than 1.
Yes, because that individual data point might shift the line. So you have to inspect it and you have to see whether any data point more than 1. So I think every data point is less than 1. Nothing is more than 1, right? So that means you can write that none of the data point was having Cook's distance more than 1. So there was no highly influential point in your data. Is it okay? Are you people okay up till this point? Because I am still left with two more concepts.
Yes, ma'am. Outliers and high
Complete silence. Yeah, Dr. Muhammad, outlier and
that high
influential.
high inflation are not in there in our data, as the Cook
Yes.
distance is less than 1.
Yeah. You can write that you have visually inspected all the Cook's distance and none of the data point is having a Cook's distance more than 1. So there was no outlier. There was no high influential point, right? Now coming to what Pragya asked regarding the AIC and BIC. So I'm just unchecking these two. And now coming to this, yes. So I have not told you these blocks. So first I'll just, can you see there is a block here? So you can enter the your variable in a block-wise manner. So first click on add block. So you may introduce these one by one. Gender. So this will make a first, you can write this thing, model, where only gender is there. Then you can add new block and then you can write age also. Then you can write block 3, admission type. So you are entering the variables one by one. So that's why you will see that in many this thing they write that, they have made model 1, model 2, model 3, something like that. I'm just entering these. This will make those many. You can like in new block, you can enter these two together also. Like I may select these two together and enter it. No, in one block you can enter. So this one and this and here. So you can see that there are 5 models here. Can you see? So you can select a particular model and you can see. So now coming to those values which Pragya was saying, the AIC, BIC. Wait for some time as it shows you it takes some time of.
And while putting the two independent variables in one class, there is another option called, that is the multiplication of that two variable.
No, that is the interaction. Interaction, I'm not telling you. This is the tab of interaction. So interaction, we are not telling you. We are only telling you the main effects. So that's why I have just removed that. So you can see here. Now coming to your question, Pragya. You have asked regarding so now I am focusing on this. Can you see this?
Yes, model fit measures.
So now you have to see where it is the least. Because in the initial one, there was no reference, right? Because they reflect the badness of it. That means the lesser value, more good. So it will tell you that this is the 415, 433, the last one. It is the least. Even this one. The last model, the model 5th model has got the least of these values. Also, you will see that the last model has the highest R square, McFadden. Right. And the chi-square should be high. It has got the highest chi-square. Right. So you will accept these model, seek the model fit statistics.
Okay. So, ma'am, we can enter all the variables in block, or we have to make the different blocks like 1, 2, 3.
It is up to you. How
For
you
comparison, it will be easy for if we can
one by one. If you do it one by
all the variables, that means it will AIC, BIC will be one above the other.
I didn't get your question, Dr. Mohammed. Can you repeat it?
If we are entering all the variables in one block, then the values will be one of, that means comparability.
There will be single value then. If in one block, if you enter everything.
Okay.
This is just to see, like, if you are taking one variable one by one, and if you are like, you just want to show that you are predicting, this is especially important when you have got a lesser number of sample size. Then also you can choose which variable to choose, or by removing which variable your model fit statistics is improving by how much. Suppose if all the variable is like less than 0.05, and then also if the sample size is less and you need to select 2 or 3 very important, then you can choose these model fit statistics to select a particular type of model on the number of independent variable.
Okay. Okay, ma'am. That means we have to enter actually each variable in block. That means it will represent it as the model with
Yeah.
respect to the dependent variable.
Yeah.
Yes.
You can do like in the last I entered 2 together. So you can do that like that. In one block, you can enter like age and gender both. In block 2, you can enter admission and department both. You can see and you can just play with these deviances, AIC and BIC, and you can decide.
Okay.
Those are a little higher one. That's why probably we are not discussing.
For our level, we have to make the different blocks. Okay. For each variable.
For your, though, I will not even suggest, since Pragya has asked regarding this AIC and BIC. So I have demonstrated this. Otherwise, you people can use the enter method where you, like I did previously, all the variables here. So in that case, there won't be any block.
Okay, okay.
There will be only one block where all the variables will be there.
Okay.
1 minute. Where like I will enter everything in this block. The way I did previously, it was, if you don't do anything, it will be like this. If you keep writing add new block, then, so it will be, it is the enter method. In SPSS, if you remember, this is the enter method of making the model. Okay, here everything is in block 1. I am not introducing one by one.
So we are getting only one AIC and BIC value there.
Yeah, that's what I said initially. So you just have to, for basic analysis, we advocate this one.
Okay.
But if you want advanced one, and since Pragya asked specifically regarding these AIC and BIC, so if you don't have any reference model to compare, you cannot comment on these statistics.
Okay, ma'am. Okay.
That's what I wanted to emphasize. I think if this is clear, then we can go to the breakout room. Yeah, or any other question, if it is there, you may ask.
Ma'am, one question.
Yes, Pragya.
Ma'am, can you please explain the interaction
Pragya, for
fact?
interaction, we may have a separate this thing. Why? Because all the other participants are also there. So definitely we will handle this. But currently we will focus on the larger, since the all other participants, they need to understand that also. So it will create a little confusion. So I'm waiting here. You go and complete exercise there probably, and then we may explain maybe right now, or maybe I'll explain it to you.
Okay, thank you.
Okay, Word document. Okay, no, before we go to the breakout room, one more command to show. So there is an option, it was in there, na survival, na? Yes. So all of you, you can download the module of survival. And in survival, if you click this odds ratio table and plot, this is the clinicopath survival. Okay. You go to this module and this clinicopath survival. No, I'm just showing, I'm not going into the detail. I was install, you can. This one. J survival or the survival module for clinicopath for Jamovi. Okay. You download, you add this. If you click this, since it is there in my this thing, otherwise you people can go see in the library and add it. Okay. And then you can go to the survival. There's an option of odds ratio table and plot. You can click this and you can select this outcome variable. This is the surgery cancellation. And you can have this gender all together in one this thing. Chronic diseases we have not taken. Admission type, department, anesthesia type. And maybe there's emergency status also. So you will see that you will have a adjusted and unadjusted odds together. Can you see? So it will give you the odds ratio univariable, odds ratio multivariable with all other variable, and it gives you a plot also here. So if you click, Dr. Anupma was asking, right click, copy, and go to the Word. And paste it. I don't know, there's some problem with you. In your case, it will not be like this. So it will be pasted. It will be like this. This one. So this is the copy pasted table. You can, yes, this one. And then you can write the description. We have written the description also. We will share it. The interpretation, maybe tomorrow also we can continue with this. The interpretation part of this. Right. So till I think we should open the breakout room since it is 4:32. And you all need to practice. So Ria, are you